Hey, this is Mr. Mitchell. Why don't we talk about naming bonds? It says up here naming two-element bonds. That's what we're going to be working with whenever you have two elements that have formed an ionic or covalent bonds. You may notice I put some up here that have more than two elements. Most of those have names, don't really seem to come from the carbon, hydrogen, oxygen that you sometimes get with things that are bigger molecules like that. So we're not really going to worry about those. Some of those you'll end up knowing just from seeing them a little bit. But anyway, we're talking about the two-element bonds. Now you may remember we were talking about ionic bonds and covalent bonds. Metallic bonds will not be in this particular video, but there are different rules for our ionic and covalent bonds. So let's say we wanted to name an ionic bonded compound like NaCl, BeF2, or Mg3NO. You have some simple rules. You put the metal first. Now keep in mind, ionic is from one side of the table to the other, which means you'll have one metal and one non-metal. So you write or say the metal first. And then every one of these ends in ID. So those are the two rules. Let's say we have NaCl. You say the metal first, which is the metal. It's going to be Na. Cl is the nonmetal. So say sodium chloride. Sodium is the metal. Chlorine should end in IDE. So that is sodium chloride. And you probably have figured out that I have written the metal first on these also. But just so we see, beryllium is Be, which is here on the metal side. Fluorine is way over on this side on the non-metal. So you have beryllium fluoride. It doesn't matter whether you have a subscript here or not as far as ionic bonds. Here we have magnesium and we have nitrogen. Magnesium is, of course, the metal. Nitrogen is not. It's over here on the far side. So following the rules, you have the metal first, magnesium, and then you have this next one ending in ID, magnesium nitride. Magnesium nitride. You know, that's pretty straightforward. Ionics are pretty easy. Covalent, however, even though they're not that hard, they're different. They're different. You may remember covalent are having to do with these non-metals, all these non-metals that are up here, and don't forget hydrogen is considered a non-metal too. When you have all these non-metals, you don't have a metal to put first. So let's see what the rules are. The farthest to the left on the periodic table goes first. Okay, so we've got something that tells you which one goes first. And then we get really different with number 2, even though number 3 is going to be the same. Number 2, you use numerical prefixes. I have numerical prefixes that you probably have heard over here. Number 1 is mono, 2 is di, 3 is tri, tetra, penta, and so on. So here's what this looks like when you have the farthest to the left goes first, use numerical prefixes, and ends in IDE. So let's take this. S is sulfur, which is right here. F is fluoride, which is right here. Fluorine, which is right here. So sulfur, of course, is farthest left, and that's what I've done with all of these. Sulfur is farthest left, so you say it first. Sulfur hexafluoride. Sulfur hexafluoride. Sulfur farthest to the left. You use the numerical prefixes, hexa in this case for 6, and it ends in IDE, sulfur hexafluoride. Let's try this one. Nitrogen is going to be farthest to the left, and we have 2 as the prefix. So, to help you find the prefix. So, nitrogen dioxide. Nitrogen dioxide. Nitrogen to the left. You have 2 for di, and it ends in IDE. So what do you think this one is? Carbon is to the left, Cl is to the right, so it's carbon tetrachloride. Carbon tetrachloride is what this one would be. What about this one? This one you have 2 and you have 5. So you have 2 of these, which really doesn't change the rules. It just means you use more prefixes. Nitrogen is farthest to the left. Oxygen is farthest to the right. So start with nitrogen. Dinitrogen pentaoxide, and they're going to abbreviate when you have penta or tetra. It goes to dinitrogen pentoxide. Dinitrogen pentoxide is what that one would be. So, you feeling pretty good about that? Now let's go backwards. Say I give you the name. Can you make the formula? Well, some of these are going to be ionic and some of these are going to be covalent. So we have to see what they are first. So lithium chloride, we have lithium here and we have chlorine here. So that is going to be ionic. And with ionic, you have the metal first and it ends in IDE. So we're going to write the metal first here. We have Li and then we're going to have Cl. So I'll just write this down here. We have Li and we have Cl. Now keep in mind we have to have the numbers right at the bottom, but this one's going to make it easy. Li is in this column, which means it has 1 outer shell electron, and Cl is in this column, so it has 7. So you do not have more than 1 Li or Cl. They automatically make the bond. What about nitrogen trichloride? Let's see where this is. Nitrogen is here and chlorine is here. So this is going to be a covalent bond. So covalent bonds is where you have these prefixes. We have one right there. So nitrogen does not have a prefix. So that means you just have N. And we have chlorine, but you see we have a prefix. So as far as writing these out, the covalent is probably easiest because tri tells you that it's going to be 3, NCl3. Now here we have an ionic, calcium fluoride. Calcium is over here, right there, and fluorine is going to be over here. So that's ionic, but this is going to have a +2 ion, and this will have a -1 ion. So you have to look at it that way. You do not have a prefix in the ionic. So we had Ca and we had F. And the question is, where do we put the number? We need 2 Fs and 1 Ca because Ca is in the +2 and F is in the -1. So we need 2 Fs. So anytime you write it out for these, you're gonna have to check on what the valences are. Oh, here's an easy one. This is gonna be covalent diphosphorus trisulfide, phosphorus and sulfur right here. So di is gonna be 2. So that would be P2. And I believe that would be 3 sulfides. So you have P2S3. And that is how you do that. Hope you learned a little bit. We'll practice it.